Tons of extraterrestrial dust particles fall to Earth every day, and these micrometeorites have hit our planet throughout history. For several years, scientists have found ancient, fossilized micrometeorites embedded in Earth rocks, and now, a new cache of ancient space debris has been found within England's famous chalky white cliffs of Dover. Scientists say studying these tiny particles could provide a new source of information about comet passes, asteroid collisions, and other tumultuous events in the early solar system. What micrometeorites from rocks tell us is the amount of space dust falling on Earth in the past, Matt Genge of Imperial College London told Seeker. This changes depending on events in the solar system. Large collisions between asteroids, for example, generate lots of dust and increase the amount falling on Earth. This means we can use rocks on Earth to detect long-past events far beyond our own planet. The micrometeorites that fall to Earth are likely cosmic leftovers from relatively recent space events. The newly found particles embedded in the cliffs are much older, said Genge and his co-author Martin Suttle, who is also from Imperial College London. The fossilized dust, they argue in a paper published in the journal Earth and Planetary Science Letters, could help explain events that took place as long as 98 million years ago, a period in the cosmic dust record that is scarce. The iconic white cliffs of Dover are an important source of fossilized creatures that help us to determine the changes and upheavals the planet has undergone many millions of years ago, Suttle said in a statement. It is so exciting because we've now discovered that fossilized space dust is entombed alongside these creatures, which can also provide us with information about what was happening in our solar system at the time. Related Martian meteorite that sparked primitive life claim gets a new look. Suttle and Genge found 76 tiny cosmic beads embedded in Earth rocks, with the tiny spherules of varying composition, from pristine silicate and iron-type micrometeorites to recrystallized magnetite. The research team said they have found a new method to study ancient rocks and look for cosmic dust, which enabled their find in Dover. The fossilization process that Earth rocks undergo can sometimes mask the identity of any embedded space dust particles, meaning some particles may have been overlooked. The recovered spherules were analyzed using an electron microscope. The particles were next embedded in resin, sectioned, polished and carbon-coated, allowing researchers to produce high-resolution images of their internal structure. Particles were then repolished and analyzed by Raman spectroscopy. The team was able to identify the samples as micrometeorites on the basis of their characteristic mineralogy, structure, and compositions. Micrometeorites have a distinctive spherical structure and Christmas tree-like shape in their crystallized content. This study demonstrates that fossil, pseudomorphic micrometeorites can be recognized and are likely common within the geological record, the team wrote. Estimates vary of how much cosmic dust and meteorites enter Earth's atmosphere each day, but range from 5 to 330 tons. These estimates are made from satellite data and extrapolations of meteorite falls. There certainly is some variation in the flux on a daily basis, he said. When we pass through cometary streams, much more dust arrives at Earth. These particles are faster and thus most don't survive to reach the Earth's surface. We can't really do this with asteroid collisions. It takes nearly 1 million years for dust to travel from the asteroid belt to Earth. Events aren't recognizable on short timescales. Genge said the best approximations for the amount of dust hitting the top of the atmosphere come from the Long-Duration Exposure Facility experiment in the 1980s, a satellite that spent 5.5 years orbiting Earth. LDEF data led researchers to estimate the amount of cosmic dust at 10,00040,000 tons per year. This agrees with the amount of dust we find in Antarctic ice, considering 90% of it evaporates, he said. The range of estimates largely comes from predictions by astronomers of the supply to Earth, or from meteor measurements that can only detect a fraction of the incoming flux. I find both these estimates, based largely on models with many assumptions or difficult observations, much less reliable than the direct measurements. I thus don't think there is much uncertainty in the flux. It is simply reconciling different measurements by different techniques with varying uncertainties. Related stunning detail revealed in solar system geology maps. Genge was part of a recent study that determined even amateur meteorite sleuths could find micrometeorites on roofs and in drain spouts. Even though high-tech instruments were required to analyze the cliffs of Dover, he said amateurs can search for micrometeorites. There is no reason why anyone can't look for cosmic dust in rocks, he said. It is simple. Crush the rock into a powder with a hammer. Run a magnet across the rock. Then using a hand lens or microscope, look for completely spherical particles. These are likely to be cosmic dust. He added that looking in rocks for cosmic dust would probably be easier than looking for micrometeorites on roofs. It all comes down to how much ordinary Earth material is there, he said. Some rocks were deposited in the deep oceans where as little as 3 millimeters of mud accumulates in 1,000 years. These muds are full of cosmic dust since they have had time to accumulate. Everyone who has ever had to clean their gutters knows how much material accumulates there, consequently there are fewer micrometeorites. Originally published on Seeker.